GCSE Physics boosters, atmospheric pressure. This is the last video in this section. We'll go on to forces and motion next. It's not a very long video, there's not any maths in it, but it's quite interesting and you do need to know the stuff in it. So here we go, atmospheric pressure. We'll start with a question. There's planet Earth. And the radius of planet Earth is about 6,400 kilometers. Now, how far from the surface would you have to travel to get into space? If you traveled straight up, if you climbed a ladder, how far would you have to climb to get into space? Do you know? Have a guess, and the answer is, well, this graph here shows that there is no actual boundary. As you go higher and higher up, as your altitude increases, air pressure, and air pressure is basically how much air there is, will fall, and that shape, we say it falls exponentially. If you've done radioactive decay yet, you'll know what that is. It falls exponentially. In other words, it falls pretty quickly to start with. Okay? And officially, to get into space, it's about 100 kilometers. So if you compare 100 kilometers with the radius of the Earth, which is about 6,400 kilometers, the Earth's atmosphere is pretty thin. Okay? Now, atmospheric pressure, how much atmosphere there is, gets less with altitude. Why does it get less with altitude? Well, basically, air, the stuff that we are breathing, can't escape from the Earth because of the Earth's gravity. Gravity is keeping the air, thankfully, going around the Earth. But as you go higher and higher up, the air particles, to get that high up, need energy. And as you go higher and higher up, the number of air particles which have enough energy to be there gets less and less. And so the atmosphere, the pressure, falls exponentially with height. I find it really interesting. You know, I live in Middlesbrough, and if I get in my car and I drive to Leeds, which takes me about an hour, if I were to drive vertically upwards, then in the same time I would get to space. Officially. Now, air is a fluid. A fluid is a liquid or a gas, and we have lots of it above our head. And so this air above our head is going to cause pressure, just like being underwater. Now, we did this equation P is H rho G in the last video. Now, we can't use that equation to work out atmospheric pressure. Why not? Because as you get higher up, the air gets thinner, so the density is going to get less and less and less. So, you know, what value for rho, the density of air, do we use? At the surface of the Earth, it's about 1.2 kilograms per meter cubed. But then the higher up you go, that density will get less and less exponentially. Nevertheless, the pressure due to the Earth's atmosphere at the Earth's surface is about 100 kilopascal. 100 kilopascal, which is about the same as being 10 meters underwater. Is 100 kilopascal a lot of pressure? So 100 kilopascals is a lot of pressure. What actually causes this pressure is the air particles banging into you. Lots and lots of air particles banging into you. If you watch my video on pressure in gases in the particle model section, I talk a lot about that. If you haven't seen it, watch it. It's dead good. Okay, 100 kilopascals is a lot of pressure. It's about the same as being driven over by a tank. Okay, 100,000 newtons per meter squared. That's like the weight of 10,000 kilograms on a meter squared. It's a lot of pressure. Now, we don't notice it because we've evolved on planet Earth. So our species for however long we've been around on planet Earth, have always been able to cope with it. In fact, our blood pressure is slightly bigger, especially in our arteries. Okay, so we don't notice this pressure because we've evolved with it. Okay, we would notice if it wasn't there. There's been quite a few sci-fi films and episodes of this, that and the other where somebody has taken their helmet off in space. Now, we know now that your head wouldn't just explode, but you wouldn't last very long. Okay, the best one I've seen, there's a fantastic series on Amazon Prime called The Expanse, and in it this young lady Naomi has to travel from one spaceship to another without a spacesuit, and honestly she's in a bad way at the end of it, but she does actually survive. Okay, as long as it's not for too long. You would survive, but you'd be a bit of a vegetable afterwards. Anyway, I recommend that.